those got turned on. Underline the hypothesis and circle the conclusion. Again, I just make sure, especially on the test, that you do read it. So for the first one, if I buy a movie ticket, then I'll watch a movie. The if and then is, I won't count off, but technically the if, well, the real hypothesis is I buy a movie ticket. This if I buy a movie ticket, if is just setting off the statement. The actual hypothesis is that. The then sets off this, what follows is the conclusion. But if you circle the if and then, I'm not going to mark it wrong, but really the if and then are not contained in the hypothesis or conclusion. It's the statements that follow. No. Because if we were being a little more nitpicky, I would, but I'm not going to make a big deal about that. But again, on the test, make sure to definitely read the instructions for that part. Questions on 4 through 6, writing the if, then. So is there one in particular that y'all want to look at? We're good with these here. Now this first one, a right angle is 90 degrees. If we did this one here, we'd have to change the wording a little bit. Because we'd have to say if an angle is a right angle, then its FURE is 90 degrees. So this one here we had to change the wording a little bit. Because I can't say if a right angle then is 90. Because that just doesn't make grammatical sense, and it doesn't quite work, because we need a way to prove it.
Can you put if an angle is 90 degrees?
Mm-hmm. Because this is a biconditional statement, it works both ways. Because if an angle is 90 degrees, then it is a right angle. So for number 5, we would have to do the same thing. We have to change the wording a little bit, because we can't say if vertical angles then are congruent. Because what are vertical angles? Well, it's how many angles? 2 angles. So if 2 angles are vertical angles, then they are congruent. Because we need a way to test it, to show that it's true. So I need a way to define what we're talking about. If 2 angles are vertical angles, then they are congruent. Our hypothesis and conclusion. Questions on 7 through 9. Biconditional statement. So these work both ways. So if a polygon has 6 sides, then it is a hexagon. So we can say a polygon has 6 sides. What? If and only if. What did the answer key say? Well, it said it has 6 sides, and then it says I, F, IFF, yes? It is a hexagon. IFF is the abbreviation for if and only if. IFF. I talked to 8th Hour about this yesterday. You can use this here, IFF. I will accept that as if and only if. Now, if you just put IF, one F, it's going to get marked wrong, because that's just saying if. 2 F's would be if and only if. So if you're not really sure that you're going to get that right, go on and write out if and only if. It's not going to take that much longer to write it out. Or IFF is also the same thing. It's the abbreviation of if and only if. It seems like a weird way to abbreviate multiple words, but that's the math community. So any other questions on our biconditional? We like the biconditional statements. Questions on 10 or 11? Number 10. So all of these here are going to be written in kind of what form? If if then, yes? So our first one, the conditional statement would be if, well, P implies Q. If P, if you do your math homework, then you'll pass the test. So that's our P implies Q. Well, then we have Q implies P. If you pass the test, then you did your homework or your math homework. So that's our P implies Q. Now the next one is our inverse if. So not P implies not Q. The little squiggle line is not, so it's the opposite. We're negating it. So if the original statement is you do your homework, you do your math homework, so the negation is you do not do your math homework, then, well, the original Q statement was you pass the test. The negation of it is you will what? Not pass the test. And last but not least, if you don't pass the test, then you did not do your math homework. So it's really just rewriting those statements out. Now on the test, I am not going to make y'all do the true false, because I mean this here is completely ambiguous because it could be true or false in either case. We could find examples to actually make all these false. So I'm not actually asking for true or false. You just need to write the statements. Questions on 12, 13, or 14? Any one of those in particular that y'all want to look at? So number 12, when I roll a dice 10 times, it came up as an even number 5 times. So there's a 50% chance of rolling an even number. Would this be inductive or deductive? It would be inductive because what we are actually observing the dice roll. We rolled it 10 times, 5 of them were an even number. So this would be inductive because it's based off of a pattern we're observing. Number 13, I am 5,280 feet away from my house. Since 5,280 feet is equal to 1 mile, I am 1 mile away from home. And it would be deductive. Because it's facts, because 5,280 feet is 1 mile. That is a fact. Every time a firework goes off, it scares my dog. Therefore, my dog is scared of fireworks. Would be inductive, based off of pattern, something we observe. Questions on 15 through 18. One of those that we want to look at. Yes. 15. If x is less than negative 2, then the absolute value of x is greater than 2. If the absolute value of x is greater than 2, then x is greater than 2. do we have something that matches in these two statements? Well, I have if and then are the same. The absolute value of x is greater than 2, yes? So what this means is I can use the law of syllogism to say that if x is less than negative 2, then x is greater than 2. Now, realistically, this new statement doesn't make any sense, but because of the fact that the law of syllogism says that we take two true statements and make them true, or that are true, we can use the law of syllogism as long as an if and then match. If an if and then match, then we can use the law of syllogism. Number 16, if I go to work, then I will get paid. If Tom goes to work, Tom will get paid. This is going to be the law of detachment. Welcome. Because Tom goes to work is showing that the hypothesis is true. If the hypothesis is true, then the conclusion must also be true. So if I go to work, then I will get paid. So the hypothesis is going to work. Because if you go to work, then you will get paid. Tom went to work, so Tom will get paid. Syllogism is we're taking two statements and making a new one. Detachment is I have a statement. Does it say the hypothesis is true? Then we can say the conclusion is also. If a figure is a square, then it will have all right angles and four congruent sides. If figure ABCD is a square, is that making the hypothesis true? Yes. So ABCD will have all right angles and four congruent sides. That's just the law of detachment. 18, if A is equal to 6, then 3A is equal to 18. If 1/2 A is equal to 3, then A is equal to 6. I do have two if-then statements, yes? They are both true. And do we have an if and then that match? Well, yeah, if A is equal to 6, then A is equal to 6, yes? Those two do match, so put the other two together, which would be if what? And this one here, because if it does match up and we can use it, it kind of gives us the setup. Because if, well, the one with if is the 1/2 A equals 3. It goes first. The other one is then 3A equals 18. It goes second, because then we have a new if-then that we put together. Questions on this here? Now this step number 3, you can really mark out. And we'll go over this proof here. Now these here on the test will be completely blank. There won't be any steps on either side. I will provide blanks going down. So if you do it the exact same way or similar way that I did it, you'll get this version. If you have less but still made every step and worked through every step and improved them and gave your reasoning and came up one short, that's fine. Okay? I'm leaving them blank because, again, there's different ways that we could go about doing them. Because you could have added x to both sides or subtracted x. Now here the first step is going to be our distributive property, multiplying through. Well, 3 times 4x is 12x. 3 times 7 is plus is equal to 5 times 3x is 5 times 3 is. Now at this point here, I mean, you could subtract 15x from both sides, yes? Because that would work. Or I could subtract 12x from both sides. Or I could start off by subtracting 21 from both sides, or subtracting 15 from both sides. Any one of those would still give us the same answer, yes? That's why I'm leaving it blank, because I'm leaving it up to y'all to figure out which order you want to do the steps in. Because this here can sometimes be restrictive on your thought process. Because what did they end up doing? They subtracted, well, that would be our subtraction property of equality. Then what did they do next? Yes, so that again would be our subtraction property of equality.
So all these steps just move up.
Yes. Yes. Because in the key, I think it would say that 3 is subtraction property of equality, 4 is the subtraction property of equality, and 5 is the division. Yeah. So again, I leave these completely blank for y'all so that you can do it how you want to actually solve it. And as long as you solve it and get the correct answer and it's justified, given your reasons for each step, and they match, you'll get the correct credit, okay? Now, like from step 4 to step 5, as it's written here, from here to here, if you subtract 15 from both sides and do it that way and write addition property of equality, okay, I'm going to mark it wrong because we didn't add something to both sides, so we subtracted. Does that make sense? So we have that there. So on these here, as long as you are showing your work or showing and explaining each step that you do to solve it, that's all you're going to need. And we always start with the given, okay? So on all of them, the first line should be the actual problem that you are given. So you'll start off with that, and we should finish with x equals or y equals at the very bottom. Questions on this here? We good with this here? Now, if you do need to add more blanks, that's perfectly fine, okay? Let's look at 21 through 25. Substitution property of equality. If AB equals 20, then AB plus CD is equal to the substitution property says I can substitute or anything in for it, because if I know that AB was equal to DF, well, then we could have said that AB plus CD is equal to DF plus CD, because if I know that they're equal, I can substitute it in. Symmetric property of equality. The measure of angle 1 is equal to the measure of angle 2, then to the measure of angle 1. And again, you can have your reference sheet on the test. You can utilize it on the test. Any other questions on 23 through 25? Are we good with 23 through 25? I believe for 26 through 29, we want to state the property being used. If PQ is congruent, if line segment PQ is congruent to line segment ST, and line segment ST is congruent to line segment AB, then line segment AB is congruent to line segment PQ. This would be what? Transitive property of congruent segments. I'm going to want the whole thing. I'm going to want the whole thing. Now, should y'all be able to spell this right? Well, yes, it's on your reference sheet. You will have that right in front of you. So 27 would be what? Distributive property of angle congruency, because we're talking about angles. And I think this is the first one, really segment congruency or congruent segments. Either one. Congruent angles, I'll take it. Wouldn't be as 100% as correct, but I'll take it. Okay? Because I know, especially if you have it right there on the sheet, it'll say it right there above it. Questions on 28 or 29? We're good with these here. Questions about 30 through 32? Well, this here would be that angle 1 is congruent to angle 3. Now, because we're talking about congruency, I need the congruency symbol. If you write line segments, if AB is congruent to CD, then, because symmetric, we flip it, then CD is congruent to AB. Because I'm still going to be marking off if you don't include the line segment or the congruency markers on these here. And you'll need your angle markers as well. Questions on 33? So any questions on anything so far? Any questions on 33, 34, 35, or 36? One of those in particular that y'all want to look at? Angle 1 and 2 are supplementary. Angle 2 and 3 are supplementary. Prove that angle 1 is congruent to angle 3. What are we starting with? Angle 1 and angle 2 are supplementary. We also have that angle 2 and angle 3 are always start with the given information. Now we are not restricted to having just one or two things. We can have more than one thing that is given. So if they do give something like this here or multiple lines, make sure all the given information is put first. Well, let's see here. What do we know we're going to prove? 1 is congruent to 3, yes? I know what the last line is going to be because the lines will be provided that 1 is congruent to 3 because that's what we're trying to prove, yes? So on any of the proofs, that's easy points given what we're wanting to prove, because either one of those on our step sides is left blank, fill those in. The second one was filled in for us. They say that measure of angle 1 plus the measure of angle 2 is equal to 180. The measure of angle 2 plus the measure of angle 3 is equal to 180. Why do we know that? The definition of supplementary angles. Well, step 3, it might seem a little like where are we going from this here, but what does the reasoning say on the other side? Property of equality, yes? So the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 2 plus the measure of angle. Because the transitive property is really saying that I'm taking two statements that are equal to the same thing and setting them equal to each other. As transitive property of equality is really saying if A equals B and B equals C, then A is equal to C. Well, they're both equal to 180, so I can set them equal to each other. So the proof, the statement, our reason kind of gave that to us. Well, now we went from this here to just 1 equals 3, yes? Well, what did we remove? Measure of angle 2 from both sides, yes? Well, they're just numbers, aren't they? Is it just a value? Subtraction. property of equality. Since we're talking about the actual measures, the number, whatever the degree measure of the angle is, it's equality. Now, if we were actually just talking about the angles themselves, then it would be congruency. Also, in the middle of those, measure of angle 1 plus the measure of angle 2 is in what? Equal sign, yes? Equals is equality. Because if we had the congruency sign, then we'd be talking about congruency. Well, and then that's it. Questions on this here? (33, 35, 36). Is there another one of those that y'all want to look at? Well, what are we starting out with?
If we like abbreviate something here.
If you have space, go on and write it out. Because I have a feeling, well, I'm writing a lot bigger because I have to with the projector, but I think y'all have enough room to fit that in. You can use the abbreviation or the symbol for and if you want. That works just fine. Well, and we're wanting to show that angle 2 is congruent to angle 3. Angle 2 is congruent to angle 3, yes? So that's where we're trying to get to. Definition of congruent angles, okay, well, most likely the step above it's going to say that their measures are equal. Definition of supplementary angles, okay. Measure of angle 1 plus the measure of angle 2 is equal to 180. Measure of angle 1 plus the measure of angle 3 is equal to 180. That's just definition of supplementary angles. And it also tells us the reasoning behind step number 2, or why we got there, as well as the definition of supplementary angles. What's our third reason? Well, these are both equal to the same thing, so that means I can set them equal to each. Next reason?
4 would be measure of angle 2.
And we're done. So really, this will be almost exactly the same type setup as they will be on the test. For the geometric proof, you're filling in the blanks. You're not doing the entire proof. You're just filling in. Questions on any of the other geometric proofs? Be ready for the next. Questions on 37 through 40. Huh? Okay. Well, so we're trying to find the measure of angle 2, measure of angle 3, and the measure of angle 4. 1 and what other angle are vertical angles? 1 and 3, yes? So 3 is 120 degrees. Now 1 and 2, 1 and 4, 4 and 3, and 3 and 2 are all linear pairs, so they make a straight line, which means the angles add together to be 180. So I can take 180 and subtract 120 and get 60, so the other two angles are going to be 60 degrees. So on problems like this here, how many angle measures, different measures will we have? 2. Because 2 are going to be the same, the other 2 are going to be the same. And really they're going to add together to be 180. And that's it. Questions on this here? So this one here, well, measure of angle 3, well, the measure of angle 1 would be 115 degrees, because 3 and 1 are vertical angles. 2 and 4 are vertical angles. Well, to find out what 2 and 4 are, we can take 115 and subtract it from 180, which would be 65 degrees. Now, I will mark it wrong if you put negative 65, because if you do 65 minus 180, it will give you negative 65. The angles that we look at in here will all be positive angles. There are such things as negative angles, but this here is going to be positive. Questions on this here? We good with 39 and 40?
That is
39 and 40 are the same thing.
We were good with it.
yeah. That's like
Let's see here. Let's look at 42. There won't be one like 41 on the test. Because we can look at it if we have time. Now these here, vertical angles are congruent, yes? Well, 18y minus 18 and 16y are vertical angles, and they both have y in them, yes? So that works. So we could say that equals 18y minus 18. Now our other set of vertical angles, these here, well, they both have x, yes? So we can set those equal to each other. Now we can't use linear pairs because 16y and 6 times x plus 2, well, that's two different variables. We can only solve for one variable at a time. Or if we do any of the other linear pairs, it will always be dealing with x and y. Now at this point here, all we need to do is solve for the value of x and then solve for the value of y. So 16y equals 18y minus 18. What's the first thing we can do? Yes. Since I have y's variables on both sides, let's move them away, or move them so that we only have them on one side. Now the 16y, since it's by itself, there's only 16y over there. Let's move all the y's over to it. Because 16 minus 18 would be negative 2y equals negative 18. What can we do next? Divide both sides by negative 2, which tells me y is equal to 9. Any questions on how we solve for the value of y? Now we need to solve for the value of x. Well, since I have 6 parentheses x plus 2, 6 outside the parentheses, we do need to distribute first. Well, 6 times x and 6 times 2. 6 times x would be 6x plus 12. Okay. What can we do first? Or next? 3 minus 6x. These will cancel. 10x minus 6x is 4x minus 4 is equal to. Now what can we do? Yep, because we do have all the variables on one side. We just need to get them by themselves. As these will cancel out, leaving us with 4x is equal to. And last but not least, divide both sides by 4, which tells me x is equal to 4. That's it. Questions on this here? We good with this here? Yes. Okay. I'll look back at this one here. Now, our vertical angles, this here, well, so we have 7x plus 4, and the other one is 10y, yes? Well, that would be two variables in an equation, yes? And we can only solve for one at a time, so that doesn't work. The other vertical angles would be 3y plus 11 and 4x minus, well, that doesn't work. Wait a minute. These bottom two here deal in just x, yes? So what are they? They are not vertical, linear pair. They are a straight line, yes? So what I can say is that 7x plus 4 plus 4x minus 22 is equal to what? 180. We can also say that the top two make a linear pair. So 3y plus 11 plus 10y equals 180. So depending on how it's set up is dependent on what we do. Because if the vertical angles like the one we did previously, x and x, y and y match up, we can use it. Here, we have to use linear pairs and solve for the value of x. So to solve for the value of x, we can combine like terms since they're on the same side of the equal sign. 7x and 4x is 11x. 4 minus 22 would be 18 equals, our next step would be 2. Add 18 to both sides, which will tell us that 11x is equal to 198. And last but not least, we would divide both sides by 11, which will tell me that x is equal to now we can do the same thing for y. We can combine our like terms. Well, that'd be 3y and 10y, which would be 13y plus 11 is equal to 180. Then our next step would be to subtract 11 from both sides, which will tell me that 13y is equal to 169. And lastly, we would divide both sides by 13. And that will tell me y is equal to 13, because 13 squared is 169. Any other questions on this here? Any other questions on any other part of the review sheet?
On 43, on the third part, would that just be,
You had one more.
would that just be number 8, angle 1, they're both right?
Yep, because that is the last step. So the part we're wanting to prove is that angle 1 and angle 2 are both right angles. So we're given angle 1 is congruent angle 2, and 1 and 2 are supplementary. So since they're congruent, it means that they are equal. And since they're supplementary, it means they add together to be 180. Supplementary angles. So, well, definition of congruent angles, definition of supplementary angles. Now, step 4, we go from 1 plus 2 equals 180 to 1 plus 1. Well, I know that angle 1 and angle 2 are congruent. They're also equal. We already stated that, yes? So I substitution, property of equality. Substitution, property of equality. I'll take simplified here, or distributive property. because we combine them together, because the measure of angle 1 plus the measure of angle 1 is, well, 2 times the measure of angle 1 is equal to 180. Division, property of equality. Because again, I divided both sides by 2, telling me that the measure of angle 1 is equal to 90. So we've proven it's a right angle, yes? But what did we say at the very beginning? 1 is equal to 2? Well, I can use the substitution property of equality to say that the measure of angle 2 is equal to 90. Well, the definition of right angles, if an angle is a right angle, then its measure is 90 degrees. If an angle's measure is 90 degrees, then it is a right angle. So we can say 1 and 2 are both right angles.
So how'd you get
We simplified it because the measure of angle 1 plus the measure of angle 1 is 2 times the measure of angle 1. I'm going to write this on the whiteboard. Really what we can say is that we used the distributive property backwards. Is I factored it out. I divided both of the terms by the measure of angle 1, and 1 plus 1 is 2 times the measure of angle 1 is equal to 180. It's the distributive property backwards. So I'll take simplified or distributive property. And really we could say with step 7 that it could also be the transitive property of equality, because the measure of angle 2 is equal to 90. The measure of angle 1 is equal to 90, so the measure of angle 1 is equal to the measure of angle 2. Or the measure of angle 1 is equal to 90, 1 is equal to 2, so 2 is equal to 90 is also the transitive property. We could use either one. Questions on this here? We good with this here? Okay. Now, you guys wanted to look at one of the homework questions? Okay, I'm going to need to grab a book. I know that the bell is going to ring shortly. Number 14. Well, we didn't even need that, because the given information tell us that AB is congruent to FG and BF bisects AC and DG. If y'all want to see this, y'all can stay in here. If you don't, you can go on and leave. I'll write a note for any of y'all that stay. Is given. This is a given information. Now, we're wanting to prove that BC is congruent to DF. BC is congruent to DF. So we've shown that the two lines are congruent to each other, yes? Because that's the whole line, AB and FG. Or, yes. Wait, AB, FD. Okay, so 2 parts. Sorry, 2 parts are congruent. Because of the overall figure, the top and bottom are congruent to each other. Now, if we want to, we can say that their measures are equal, but the final statement was still talking about them being congruent, yes? So I don't have to talk about the measures being equal. Now, because BF bisects AC and DG, I can say that AB is congruent to BC. because it cuts that line in half into two congruent parts. We can also say that DF is congruent to FG. This is the definition of segment bisectors. Because by the definition of segment bisectors, it cuts a segment into two congruent parts. Yes? Well, and we're wanting to show that BC is congruent to DF. There's probably going to be another step in the middle, but well, AB is congruent to BC. So we could say that BC is congruent to transitive. This is kind of a stretch. Transitive property of equality. Is they're probably going to want to step in the middle. Because we could almost say that BC is congruent to FG as step 3, which is the substitution property of equality. And then from there, so since we had BC is congruent to FG, well, with this other statement, I can say that BC is congruent to DF. But that's it, because we got there, didn't we? That's it. So a lot of the, huh? I think so. You can double check Google Classroom if you want, but that's fine.
If it's not right, I'll come back.
So that's it. Now, a lot of the proofs, we want to make them more complicated than they are. But really, all I'm doing is utilizing what I know and trying to get at what I want. So only utilize what you have or has been given to you, or we know, we can assume.